Going to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff. And you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi, my name is Henrik Warne and I am from Sweden. I work as a software developer at Trioptima in Stockholm. For most of my career I've been a software developer, but I've also spent a few years as a tester. And both as a developer and tester, I find bugs fascinating. For the past 18 years, I've been taking notes on the trickiest bugs I've come across. And I'll talk about what kind of information I've been recording, what categories of bugs that I've found, and what I've learned from them.
Hello, and welcome to Learning from Bugs. I have two reasons for giving this talk. The first one is that this method that I've been using for 18 years now of recording tricky bugs has been really helpful for me. So I thought it would be good to share it, and maybe somebody else can use the same or a similar method. And the second reason is that I've gone through all these bugs that I've collected, and I've looked for patterns, and so I'll present what I found about these patterns, and that's in coding, testing, and debugging are the categories that I've found some lessons. But first, I'll just give a little bit of background about myself. I'm a software developer at Trioptima in Stockholm. Previously, I worked at Simsoft, Tilgin, and Ericsson. Ericsson is well known. I think the other ones are not. They're all in telecom though. But this job at Trioptima is in financial services. I've been programming for more than 25 years. I still love programming. I code every day at work. Currently, I am working in Python. In the past, I worked in Java, C++, and Plex, which is an Ericsson proprietary language. I am blogging at henrikwarne.com, and my Twitter account is Henrik Warne. Right, so tracking interesting bugs. So what bugs are interesting? Well, most of these bugs are bugs that are found in production. And I find that kind of interesting because, and also I should say, most of these bugs that I write about or take notes on are bugs that I've caused myself. I think about 80 of them I've caused. So I find that kind of interesting, that I coded the feature, I tested it myself, somebody else tested it, it went into production, and still there was a bug in there. So something is it's something with these bugs that I want to learn from, because I don't want to release bugs into production, but it happens. So I want to learn from those cases. And these are not just your average bug where you forgot an if statement and then as soon as you test it, you realize it. It's more trickier ones like that, so they get all the way to production. And it can also be bugs that teach me something about the language, for example, that I didn't know about before. So I misunderstood how a feature works, and that's what caused the bug. So in all of these cases, it's something that I think I should learn from them. And I've found that when I write things down about these bugs, it helps me to learn much better than if I just try to remember it when I think about it. So writing it down gives an added help to learning. And also, when they're written down, I can go back and review later. And the way I do it is very, very low tech. It's just a plain text file that I keep, that I call bugs.txt, and I keep adding entries to it. I actually have a template for it at the top of the file, and every time I want to add a bug, I just copy the template down and then fill in the headings. And I'll show you what the template looks like. So here, these are the headings that I fill out for any bug that I want to enter. So most of these headings are self-explanatory. I think the date when it happened, the symptom, how it was noticed. Sometimes it's the headline of the bug ticket, if somebody writes it. The cause of it, that's where I write, how did this bug actually happen? It's a little bit of a description. And I have a section called How Found. And in it, I write down the steps I took when I was troubleshooting, because sometimes, you know, you look in the wrong place and you don't get to it right away, or it can be hard to find. And it's useful to see what were the steps I used to try and pinpoint it. For the fix, it can sometimes just be the code that I changed to fix the bug, or sometimes it's just a short description of what the fix is. I added fixed in which file early on, and I thought that it would be helpful to know if it was the same file happening like many times, but I haven't found that so useful actually. But I still enter it because it's very easy to add the file that it appeared in. Was it caused by me? Yes, at least 80% of the ones are caused by me. If there are some really tricky bugs that somebody else wrote, but I helped debug, then I still enter it because I can learn something from it. The time it took to resolve it, I can usually it's be like half an hour, or if it's longer, I will write days instead. And the most important heading is the lessons. And that's where I try and summarize in like a few sentences what lessons should I learn from this particular bug. And these are the ones that I can go back and review. So it's kind of quick to just look at the lessons for each of the bugs. So I'll give you 2 examples of bugs just to give you a feel for what kind of bugs that I enter. And the first one, this one happened actually just the other, about a month ago. And it was an event listener that was crashing in UAT, and it said value too large. And it was trying to put a value into the Cassandra database that we use. But the problem here was the column in Cassandra was defined as an int, and in the Python code that generated the value, it was also an int. But they're not the same ints. In Cassandra, an int is a 32-bit number, but in Python 3, the ints are unlimited, basically. But it was a value of about 6 billion, and that was too big. Like about 2 billion is the limit for an int value a 32-bit value. And so I thought this was an interesting case because the ints, it says int both in the table in Cassandra and it's an int in the code, but it's not the same size. So this is what I wrote in that case. You can see that happened on September 16th, so quite recent. The symptom, it's just the header of the ticket. I actually usually include the Jira ticket number as well, so I can look back to that if I need to. The cause of it, you see there, it's like 2 sentences description. Yeah, 6 billion yens that was entered. And how was it found in this case? Another developer just noticed that the listener was crashing, so that's how we started investigating. We were happy it didn't happen in prod, it was only in UAT. But the code had been released for like maybe a month before, but nobody had entered 6 billion before. So the fix changed the type in Cassandra to big int instead. And that will give enough, that's 64 bits, and that will give enough room for any realistic value for this field. Fixed in file, yeah, schema.sql. Was it caused by me? No, in this case it wasn't, but I reviewed the PR and I didn't see it, so that's kind of worth noting. How long did it take to resolve it? I wrote 1 day, mostly because it was hard. You can't just do alter table. So in the end, we ended up copying the whole table to a new version where that field was set to big int instead. And the lesson here, I think it would have been good to test with a value greater than 2 billion, but we didn't. And also tricky that it's the same int in both cases, but different meanings. Okay, so for the next example, this is an old one. It's from all the way back from 2004. And this has to do with TLV encoding of messages, which is used a lot in telecom signaling. And then, so you want to send some bytes and you have a tag that identify what the bytes mean, maybe their phone number, the length, how many bytes are the values that are coming, and then the actual values. And if you can see from the picture here too that you can nest these as well. And this is quite a good way of encoding messages because you get like forward compatibility. You can have old code that handles newer messages because it can just skip tags that it doesn't know about. So the problem in this case was that we got a length value that was 0. And in our code, we were trying to skip tags that we didn't recognize. And in this case, we were trying to skip ahead 0 steps. So we ended up in the same place that we were before. So this actually caused an infinite loop. And I thought that was an interesting problem because it never occurred to me that we could have a problem with 0. We had code that checked that the length wasn't outside of the buffer to be sure that it wasn't too high value, but we never thought about too low value. So this is what I wrote in that one. An infinite loop for this Q931 message. And you can see this is what I told you, just put in words here. Length 0 means we just kept going to the same point. How found? This is a bit of a longer story because it wasn't actually found in production. It was a message that we had cut out and pasted in, and then it happened to be longer than the buffer, and we got zeros. So it's a bit of an odd case, but it's something you need to be protecting for in the code anyway. So it was good that we found it. The fix that we did, we just set, if the length is 0, we set it to 1 to be sure that we at least advance. And then, of course, in this, it was an invalid message, so it wouldn't be parsed into a real message, but at least we got rid of this infinite loop. It took an hour to fix. And the lesson that it's not just big numbers. You have to be careful for 0 as well in these cases. So for when I'm doing this, I've noticed that it's really important to try and write it down as soon as possible, ideally within a day. Because usually when you're debugging something, you're in the middle of doing something else, you're testing something or doing something, and then you have to debug a problem that you hadn't thought about. So usually, once you find a problem, you really breathe a sigh of relief, and then you want to continue. But then it's easy to forget all the details. So if you write it down right away, when you have all the details in your head, it's much easier and quicker to write it down than if you wait. And I've found if I don't write it down within a day or so, I never write it down. So it's important to write it down quickly, I think. And actually writing it down, like I mentioned before, when you actually write it down, it helps you think about the problem more clearly, and it makes it makes me question anyway, like, was it really like that? Why was this? And I get a much deeper understanding of the problem when I try to formulate it in text. And of course, it's up to you what bugs are interesting. And I mean, this is all for my own benefit. I decide if I want to write something down or not, and I decide what's interesting. And here are some statistics as well. You can see that for this goes all the way back to 2002, and there were a lot of bugs in the beginning. And I also noticed when I gave this talk before that in the beginning I was coding in C++, and then in the middle I was coding in Java, and now at the end I'm coding in Python. And so somebody asked me, were those bugs because you were in C++? Because there were some bugs where there were like strings that weren't null terminated and stack overflows and stuff. But it turns out it wasn't because of C++, but I'll get to what those kinds of bugs were later. And also interesting, I think, is for the past 10 years or so, the average it has been kind of steady at around like 6 bugs per year. So that means about every other month I will write something down. And somebody else also asked me if it's the same bugs coming back again. But when I look, it's hardly ever exactly the same bug. So in a way, it seems to be working that I'm not repeating the old bugs, but there are still bugs happening. Here is also like some statistics on how long they've taken to resolve. I don't know if you can draw any conclusions from this. Most of them are quick to resolve, an hour. And then when it takes more than a day to work on them, then I just don't enter the number of hours. I just say 2 days or 3 days, or the max here is 3 days, and the longest I've had is like 7 days for one bug. Then we just spent 7 solid days trying to figure out this one bug, but that's thankfully very rare. Okay, so that's about how I'm doing this and like what I enter. So, but then I will also, for the second part, go through what I learned when I reviewed all of the bugs and tried to group them into categories and see what kind of problems had happened more than once. And so these are like the lessons I've drawn from looking at all these bugs. It's more than 230 now. And so the first category of lessons is for coding. And the first one is for event order. So what happens if normally you expect like maybe this event and then that event, but what happens if they come in a different order? The other event comes in first. What happens? What should the code do? Another case of this is if you never receive an event you're expecting, like maybe you need to start a timer, put timeout if you don't get the response you're expecting, for example. What happens if you get the same message 2 times? How should that be handled? Because and many of these problems have happened when there was a bug in a neighboring system. And so that bug caused it to behave strangely. And that's when you got the messages out of order and stuff. And even if that's not a normal case, you still need to handle it. And that's where a lot of the bugs came in. You got like these weird shouldn't happen cases, but what should you do? You at least shouldn't crash, for example. So that's the first one. That's happened a lot. Events coming in different orders. And a special case of event order is when things happen too early. And that's happened a couple of times. That was quite tricky. In one case, when I worked at Simsoft, we had systems for sending SMSs in mobile systems. And when the system restarted, we had a case where we allowed traffic to come in before all the configuration was ready and set up. So, and that caused a lot of weird cases because the configuration wasn't ready. So some things weren't configured, but we still got traffic and tried to handle it with this half-baked configuration. And another case that took a really long time to find was we had a list with devices and when they were marked down, they should be taken out of the list and because they couldn't be used. And we still had cases where devices were in state down in the list. And it actually went on for like several months. We added more debug code and double checked every time it went to down, it should be taken out of the list. And then finally, we found out that there was a race condition when the device was created. So when it was put into the list, it was already in state down. And I thought that was really interesting because it never occurred to any of us that it could be in state down already when it was put in. We were so fixated on that it got set to state down when it was on the list, in the list. So that was an eye-opener as well, to be looking out for cases to happen earlier than you expect. Silent failures. I think everybody knows that it's really bad to fail silently, and the bugs become much harder to find when that happens. But it still happens sometimes. And one case is when you do system calls. You need to really check the return code to see that it succeeded, like if you do a bind or if you get more memory. Because if the system call failed, you just should throw an error. And the best way to handle this is to always throw an error, and then you have to either crash or find ways to recover in the other parts of the code. Another surprising thing I thought was that if statements were involved in quite a lot of cases. It's such a simple concept, like very basic building block of programs, but still there were many bugs for, like, if you have nested if statements, then the else part maybe comes out at the wrong place. You don't expect it to be in that else part, you expect it to be in another else part. And another thing with if statements I've seen a lot is you have if, quite a complicated expression, and then you have right below a slightly different expression that somebody added, and you have like long chains of these if statements that vary slightly, but it's very hard to figure out which one should fit in. And so I think these days it's I try to like rewrite these complicated if statement chains so that it can be a function that can be unit tested properly, and then I can feel more confident that it's correct. Else is another one. If you have an if statement, you often also need an else statement, and at least you need to ask yourself what should happen if in the else part, because often something should happen there. And related to this is if you're setting a flag, when should it be cleared? Because there was a case where the flag was set and then the program kept going, and then it came back and then the flag was already set and you got the wrong handling. So you need to think about where should the flag be reset as well if you set it. And for all of this, logging is really important. I actually wrote a blog post just a couple of months ago about what I consider good logging, because I think logging is always needed when when you're debugging things, and not too much, not too little. You need to have enough so you can debug, but not to fill up the logs. And some people say, well, if you just catch all the exceptions, you're fine. But I mean, often the failure is that the logic does the wrong thing. There's no exception thrown, but the logic does the wrong thing. When I worked with SMSs, there was routing, finding the cheapest route for SMSs. That was quite complicated logic, and you have lots of configuration. And there it was really helpful to log all the decisions along the way on how to route it, which routes were taken away because they were too expensive. Because even if the configuration was there, it was really hard to work it out in specific cases. So having the log saying we threw away this route because it was too expensive, that really helped when you were trying to find the cases that went the wrong route. And changing assumptions is maybe the trickiest of all these things, because if something changes, it's easy to find if the signature of a function changes. The IDE will help you to find all the cases, but sometimes you've used implicit assumptions about how things work. So, for example, if you say that there is only one customer event per day, then there will only be there won't be more customer events than there are customers. So if you've used this knowledge somewhere in the code, and then all of a sudden you allow there to be more than one customer event per day, then that code might break because it's still assuming there's a maximum of the number of customers. So many events can happen, but now more can happen. And how can you find these implicit assumptions? I haven't found a good way for this. Maybe not using implicit assumptions, but that happens, I think, in the code. But the best way is really if you know the code well, so you know where this is used. But it's been some really tricky bugs where assumptions have changed, but not in all parts of the code. Right, so for testing, these are the things that I've found have caused a lot of bugs for me. Zero and null, and I think this is really well known as well. For strings, for example, it can both be null and it can have a length of 0. But this 0 and null can happen in other cases as well. There was one case where there was a TCP connection, and when you disconnected it, there was an exception because you tried to count statistics. But in this case, there had been no bytes sent on that TCP connection. So it hadn't been considered that there could be a connection that had no bytes sent and then it was disconnected. And these 0 checks should be both in your automatic tests and also in exploratory testing. I think that's a good one to try when you're exploring. Add and remove is another one. Often when you code, you add new features, so it's natural to test that you can add this new feature, you can start using it. But you also need to test taking it away, like removing the new profile that you created, and seeing that you can undo what you've done, so to speak. And that's where I've failed my tests a lot of times. I didn't test for those cases where I needed to remove things. I just tested the add in it, and then I left it there. Error handling, it's notoriously hard to test because there are certain conditions that have to happen. I think a good way is to separate the triggering of the error handling from the actual doing, because then you can test the doing separately. And often what I do too to test error handling is that I change something in the code. Like if it says if error count is greater than 0, I'll change it so if error count equals to 0. So then even if there aren't any errors, I'll trigger the error handling and just see that it works. And another similar thing is like sometimes I would change the name of a database column just so that you can see that the database exception works all the way up and see what happens. And random input or fuzzing, I think this is really, really useful. It's hard to use in some cases, but when it's applicable, it's really, really good. When we tested H323 messages, they use a binary encoding, and there we just sent random bytes to the decoder, and we found a lot of problems from just these random inputs. And another case was when I worked on VoIP calls for set-top boxes, and there we generated randomized phone calls, like a lot of calls, and tried to like have like you dial a number and it answers, and you hang up, and you try to do that. There's a lot of phones that call each other, and that random actions between the phones revealed a lot of errors, and that's actually what caused that big spike in the beginning. A lot of those problems were caused by these random phone calls that exposed a lot of problems, like signals meeting in the buffer and stuff like that. Another thing is to check what shouldn't happen. It's so natural to just see that, look for this should happen, did it happen? But you also need to keep an eye out for things that shouldn't change and make sure they don't change. And this, especially in exploratory testing, it's really good to keep an eye out to see that things that shouldn't change don't change. Writing your own tools it's been really useful for me. When I was testing the SIP VoIP protocol, for example, I made a little script, like 10 lines, that just replied to messages. And with this script, I was able to send back the right sequence numbers and stuff that had to match for it to be a valid message. And this tool I ended up extending a lot so that I can test a lot of different scenarios easily. And I think the advantage when you write your own tools is that you get exactly what you want. I mean, there are many tools you can buy for things, but sometimes they don't do exactly what you want. If you write your own tools, you can get exactly what you want. And many of the tools I've written, I've started really small, and then gradually they've grown as they've been shown to be useful. So you don't risk much by writing a small script in the beginning, and then you keep adding to it. But of course, testing won't find all the bugs. And here was a good example of that. We were generating dynamic routing numbers that were used for like a second or less. And the problem here was that it consisted of a fixed part and a dynamic part. But the bug was that the one digit too many was cut off. So in the example here, the 3 was also cut off, but it shouldn't. And that meant that for numbers from 000 to 099, it didn't matter that we cut off the highest digit, because it didn't make a difference. But then as soon as you got to 100 and all the way up to 999, then it mattered that you cut off the wrong digit. So when you tested it, it worked for the 100 first times, and then it failed for 900 times. And of course, we didn't test it more than 100 times, so we didn't find this problem in testing. Right, so for debugging, by far the lesson learned from the bugs, by far the most common one is to discuss with a colleague, and especially for the hardest bugs. It's been so helpful to discuss with a colleague when you can't figure something out. And this is kind of the same, like the rubber duck theory, that if you say something, if you explain the problem out aloud, then you realize it yourself what the problem is often. And I found that to be true. And colleagues also, even if you don't realize it, if you ask a colleague, what can this be? Even if they don't know the code so well, they can always come up with good suggestions what to continue with. Like, could it be this? Could it be that? So it's fantastically helpful, I think. And it's the things that I've the thing I've written down the most about what helped. Another thing when debugging is to pay close attention. Very often I've made false assumptions. For example, I thought it was a null pointer exception that was thrown, but it was another exception, but I didn't look closely enough. I just saw an exception and I assumed it was a null pointer exception. Or I look in the code and I wonder what happened in this function, but we never got to that function in the first place. Or we got to that function and got past it and the error was in a function later on. Or that it was a different version of the software running, that I didn't check which version was running when I was debugging. Or another really tricky thing that has happened to me too is you have some debug printout that says A equals a number, but because you copy pasted this, maybe it was the wrong parameter. It wasn't A that you printed the value of, it was B, and that can really throw you off as well. So paying close attention has been key many times. The most recent change is often the culprit. I think this is also maybe quite well known. One case, I was just changing logging code, and then we started to get null pointer exceptions. But it turned out in the logging, we actually used a field that was null. So that I was surprised at first because I thought changing the logging wouldn't cause any errors. And another tricky one was it was a very old commit that caused the problem, but the merge was done recently. So when you merged it in, you got this old commit that contained the bug. So the most recent change was a merge in this case. And of course, continuous delivery really helps when in this regard, because then you haven't changed that much. And if the problem appears, you know at least it was in the last thing you deployed, which hopefully is very small. Believe the user. Many developers tend to say, you know, that's impossible, that can't have happened, they must have done something else wrong. And I've been thinking that myself, but I've changed because I've seen so many times where a problem is reported and at first it sounds impossible, but then it turns out that that's what happened. And often it's because they've used the system in ways we hadn't thought about, or they have configured it in a weird way. So, I mean, if you get a trouble report, of course, you need to check some basic things to see that everything is fine, but you shouldn't think that's impossible or they're wrong. You should assume they're right, because I've seen from experience that happens a lot, that they actually are right in what they see. And then finally, just some common sense thing, that you want to recreate the problem so that you can see it happening locally. And if you can't recreate it, then maybe it's not really a bug or you haven't understood it properly. But when you can recreate it, you have a test case to recreate it, and then you apply your fix, you run the test case again, you see that it's fixed. You have to do that for all the bugs you come across. Yes, so to recap, I think it's been really helpful for me. I started this a long time ago. I'm still doing it, and I'm doing it because I think it's been quite useful for me. And it's so easy to do. You just need a text file and you add little notes on the bugs that you think are special in some way. And by writing it down, you really think about it a lot, and that's quite good as well. It makes you think much better, I would say, than if you just try to make a mental note or something. And the key thing is to write down what lessons you've learned from this bug, and those are the ones you're trying to avoid to repeat. And if you want, you can review these lessons later on, and then it's quick to jump through this, just a lessons section. Okay, so that's it, and I'll see if there are any questions. No, I don't really see any. But otherwise, I'll join the Zoom room for the Ask Me Anything sessions. Yeah, I'll do that now. And if you have any questions, you're welcome to join and ask me. Thank you.